Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website, arifpat.me. You can click the appropriate link under the lecture resource column to view the notebook in NB Viewer and run it online in Binder. Well, the other way is to download the notebook file from the course GitHub account, Arif and all the notebooks for this course are housed in the public data science repository. Well, this is the Jupyter notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 3.15 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. My dear students, today's session is a continuation of the previous session in which we discussed modifying the data frames. Right now the Pandas version is 1.3.4. Okay, my dear students, the learning agenda of this notebook. Remember, my dear students, once again I'm showing you this image of data frame, and Pandas data frame, as we all know, is a two-dimensional label data structure with heterogeneously typed columns having both the row indices as well as the column indices. The previous session was also a bit about modifying the data frames, in which we discussed as how we can change the column names of a data frame. We discussed in detail as how we can change the row indices of a data frame. And we also talked about that how we can modify the data inside the data frame, row wise, column wise, element wise, and so on. My dear students, today we will continue ahead and we will see as how we can add a new column in a data frame, how we can delete an existing column from the data frame, how we can add or append a new row in a data frame, how we can delete a row from a data frame, and how we can perform this deletion of rows and columns based on specific condition. And finally, we will see as a bonus two sorting methods used with data frames, sort underscore values and sort underscore index. So we have lot to do today. Let's start playing. Okay, my dear friends, as usual, first of all, let us read a data set, same old data set, group data.csv. Read it using the read underscore CSV method of the pandas and populate our data frame. So this is the data set on which we are going to do most of the examples today. And of course, I have just shown the head, the first 5 records. Actually, it has 16 rows and 10 columns. And let's see the indices. The default indices, they are starting from 0 and go up to 15. The columns are 10 and these are their labels. And remember, this roll number has a space as usual in between. And the data types of all the columns is also shown over here. Age is integer, subject 1, subject 2 and scholarship, they are float, and rest are objects. Okay, so let's see first of all how we can add a new column in a data frame. My dear students, to add a new column in a data frame, what we do is we create an appropriate series object and then we assign it to the data frame. Let's see this. So these are the existing column names. Let me add the marks of subject 1 with subject 2, and this we have seen in our first session of series, that we can always add, we can perform 2 operations on the series objects and they will be added column wise according to the indices. So this is subject 1, this is subject 2. I am adding these 2, so it will also return me a series object. You see, this is a series object, and you see if there is any of the values is NaN, the resulting answer is also NaN. We can also use this add method instead of using this plus operator. So this is a series object. And once we get the series object, what we can do is additional task to the add method is that instead of this nan, if we want that some value should be there, we can pass this fill value argument to this. So we are saying that fill value 0, so that means this will at any place where we have nan value in any of the column, it will place a 0 over there. So at this place at index 12, we have now the marks of one subject which were there in any one of the series object, either subject 1 or subject 2. Okay, so we have seen this in detail. So anyway, the main task was that we have successfully created a series object, which is the sum or total of the two subject marks, subject 1 and subject 2. And now the task is very simple. We simply assign this series object to a new data frame. So this column name is going to be crucial. If this is the same column name which already exists, it will be overwritten. But since over here, in this case, the column name total does not exist in a data frame, so a new data frame will be created. And note that once you run a cell, as usual, it's been quite time that we have been working on Jupyter Notebooks. If nothing happens and nothing turns up over here, that means some processing has been done in the background. So, and over here, the processing is a new column has been added to the data frame. Let's confirm this. Great. So we have successfully added a new column in our data frame total, which contains the sum of these two columns. Great. Let's see now how we can delete an existing column from our data frame. My dear students, you can use any of these three methods or techniques to do that. The first is use the del keyword and you pass that the column name in the subscript operator. In this case, if you use the del keyword, it will remove the column, but it will not return it to you. And the pop is a method that is passed the column name. It will remove the column as well as return that column, deleted column to you, so that you can use that if you want to. And finally, drop is the method that is better than these two because it can delete one column as well as it can delete more columns. It is not in place. Moreover, it can be used to delete the rows as well if you mention the axis. So mostly people use drop when they are deleting columns from the data frames. But anyway, for completeness, we will see all three methods. First of all, the del keyword. My dear students, let's once again see the total columns. We have, these are the columns. You see the total column is there. Let me delete this column simply using the del keyword and check this out. The del keyword, using the del keyword, we have successfully deleted the total column. And remember, this is in place. This has happened. It is not that the original DF is the same. It has been changed. So this is del. Let's see the pop as well. So let me pop the address column. Remember, we have the address column over here after the age. So I'm using pop. So you see the pop has returned the column over here to us. And if I check out the original data frame, the address column is no more there. So that means this pop is also in place. Let's check out this drop. Drop is more powerful. You can pass a list to the columns argument to drop, and all the columns which you have mentioned inside this list will be dropped. Moreover, you can mention the axis as well. If you want to drop columns, you mention the axis as 1. And normally by default, the in place is false. And if you want it to happen in place, you can make it true. Great. Once again, let me refresh the data and read this group data.csv file in our data frame DF. So this is the file, and let me drop the column name. Okay, so the column name has been dropped. My dear students, you can always drop multiple columns at the same time. Over here, you can observe that I am dropping the name, age, address as well. So the name, age, and address, all these columns have been dropped. And remember, nothing happens to the actual data frame. This is not in place. Let me show this to you. You see, over here we do not have name, age and address, but over here in the actual data frame, the name, age and address column still exist. So if you are satisfied with this result, you think that this is perfectly fine, you want this data frame, so you can pass the in place argument as true. So you pass the in place argument as true. Now you see that once I made the in place argument to true, this drop method returns none. It has not returned anything. However, in this case, once the in place argument is false, the drop method do nothing with this data frame. However, it returns a copy of the new data frame which is having this name, age and address dropped. This is a very important concept. Most of the methods follow the same techniques which have these in place arguments. Okay. So, oops. This error is because I have run it again. So to avoid it, let me refresh the dataset. And now let me come up over here and let me drop these columns. In place is not equal to true. Okay, so and now once again this will not give me any error. Great. Processing has been done. The DF has been updated and the drop method has returned none. Great. And now you see age, address and name are no more there. Great. So let's move ahead and now talk about how we can add a new row inside a data frame. My dear students, you can use append method using which you can add a row inside a data frame, or maybe another data frame can be appended with an existing data frame. We will see this append in detail once we will be talking about concatenation of data frames as well. Anyway, for the time being, just remember that this is our data set once again, and this append is going to append at the end of the data frame of this data frame. So I have used tail instead this time. So these are the last 5 records of this data frame from 11 index to 15 index. And what I am doing over here is I am just creating a new data frame. So I have called the data frame method and I am passing it the data argument. And the data argument contains a list of all the values that I want to insert inside a row. And to the columns as well, I am mentioning all the column names as well. Remember, this value must match with this column name. So this is roll number, this is the column name roll number, this is age, and this is the column name age. This is name, this is the address, and this is the address column. One more thing you need to remember, that these two must match. If we have 10 data values, we should have 10 column names. If we have 9 data values, we should have 9 column names. Okay. One more thing is that these names and values of columns need not to match with the existing column names of this data frame. Note that over here roll number is the first column and name is the second column. Over here roll number is the first column but age is the second column. So we have mentioned age before this address. And the name is not there. We have missed name. So that means you can miss a name as well. Let's see this practically and understand that. So we have roll number, age. We do not have name over here, and rest is same. So we have this data frame. We have created another data frame, and we want to append this data frame with this data frame with all these limitations. And over here, I have created this one. So this is again this DF, and this time what is the difference between these two? Over here we do not have the scholarship column. So we do not have the scholarship column. Okay, and over here we do not have the name column. Okay, great. I just want to hamper this point. And note that this new row that I have created or data frame I have created, the only index is 0. So this index once appended with the this DF will may create some issue to you. However, in this case, if you will append it, it will successfully append it. But you will always like that this new row should have the index 16 instead of 15. So let's see. This is the ignore index argument that will come for our rescue. You see this ignore index has successfully placed this new student record who belong to Kamoke at the end of the existing data frame, that is this df, and the index is 16. It is not 0. If you do not pass this argument, it will be 0. So my dear students, remember this append is a method that is passed another data frame containing one or multiple rows, and it is called upon on an existing data frame. So these two data frames are appended. Okay, I have also mentioned that this ignore index is equal to true argument. If set, then it will assign the next argument to this one or multiple rows. Okay, moreover, the NaN values, note over here that under the scholarship we have an NaN value. This is because that this column that we have, this row that we have added does not have the scholarship. So we have an NaN over here. And one last thing is this df dot append method do not have the in place argument. So you have to assign it to the original df. On the contrary, we have seen above that the drop method do have the in place argument. And I do not know the actual reason why this append does not support the in place argument. If anyone can check out and let me know in the comment box, I will be grateful. Okay, let's move ahead and see how we can delete an existing row from a data frame. My dear students, drop method can be used to drop one or more rows. You just pass it the index argument this time instead of columns, and the axis is set to 0. Okay, great. If you want to drop a single row, you can mention that. If you want to drop multiple rows, you can mention the list. And once again, by default, it is not in place. So let me refresh the data set, data frame. So this is our data frame, first 5 records. Let me drop this 2 Shaista and 4 Zara. So let me drop these two students, these two rows from this data set. Note that the axis is now 0. My dear students, this is very important. Remember, we have talked in the beginning that there are two axes inside a data frame. One is the 0 axis that moves from top to bottom, and along the axis 0, actually the rows changes. And if this axis is 1, it moves from left to right, and along axis 1, as it moves from left to right, the column changes. So whenever you want to perform an operation on columns, you make axis is equal to 1, and whenever you want to make operation along the rows, you make axis is equal to 0. I hope this makes sense. So let's do that. Nothing happens, so that means drop has successfully dropped these two values from this df, because the in place is true. If I have made in place is equal to false, it would certainly have returned the resulting data frame, a copy of the resulting data frame, without making changes to the df. But this time it has made changes to, oops, I have run it again. Okay, now it's okay. So actually I run it, I ran it again, and because for now these two records were not there in this df, so it raised an error. So I should not have done that. So anyway, now you can see the records with the indices 2 and 4 were not there. 2 Shaista and 4 Zara. So Shaista and Zara, these two students have been dropped from this data frame. Great. So we have seen as how we can delete existing rows, one or more, from a data frame using the drop method. Remember, the drop method can be used to delete rows as well as columns. Now let's see how we can add a new column with conditional values. Okay, so we have seen that we can easily create a new column, and we have seen that we have added 2 subjects and created the total column. Let's see how we can have conditional values inside the columns. And Over here, this is an example that says, let's suppose that we want to add a new column over here, the total column, which contains the sum of the subject 1 and subject 2. And after we have created the total column, we want that if the total is greater than 150, the sum of these two marks are greater than 150, we should have a column over here, let's suppose grade, which will say that you have good grades, otherwise it will say that you have bad grades. So for that, first of all, we are going to create the total column for this data frame. Now we have this data frame which has a total column, sum of subject 1 and subject 2. Now you see I have used the list comprehension. I have just created a list which says if this value, this total value is greater than equal to 150, I need to have a good over here, and if it is less than equal to 150, I need to have a bad over here. So this is list comprehension. I am creating a list, and over here I am saying that for every I in this column, for every value of this column, do what? Do this. This. So this is a ternary operator of we have talked about this in selection structure. That if I is greater than or equal to 150, if this condition is true, assign good to that appropriate value of the list, otherwise assign bad to the appropriate value of that list. So this will generate a list. Great. And we can easily assign this list to another column over here, and this is what I have done over here. You see, I have just copy pasted this code over here. I could have written just list 1 over here, and I have created a new column over here named grade, and I have assigned this list to that. I hope this makes sense. So greater than 150, good. Less than 150, bad. Less than 150, bad. Greater than 150, good. Great. So my dear students, this is how we can add a new column in your existing data frame with conditional values. And there are a lot of scenarios when you need to do this while performing your data science tasks. Okay, similarly, you can delete rows based on a specific condition. So let's see an example of this as well. Once again, this is our default data frame having these 10 columns, and let us drop an entire row from this data frame in which we have this session as afternoon. Okay, name is Mars. So this is in which session is afternoon. I have changed this because I just wanted to tell you something else using this example, where session is equal to A of t. Okay, sorry for this. My dear students, what I am doing over here is I am getting the indices of all those rows which have the session A of t. In case I would have selected a single student, it would have returned me a single index. But over here, it will give me a list. Let's see that. See this. So this is saying return me the values where session is AFT. Remember AFT, not afternoon. And this dot index is actually going to return the indices of that very particular row. And those indices will be saved in this. So we have 1, 4, 6, 8, and 14. So we have 1 AFT, we have 4 AFT, and of course after this we have 3 more records, 3 more rows where we have AFT. So these are the indices. We have successfully got the indices. Now we can easily use the drop method, and this time to the drop method, once again I have passed the list of all those indices which I want to drop, and in place is equal to true. Let me make it to false so that I should be sure that I want to do this or not. Yes, I don't want to see this DF. Okay, and yes, the job is done. AFT, there is no record of AFT. Index 1, 4, 6, 8, and 14, they all are deleted from here. So this is okay. Let me make it to true. And once I run it, it does not return me anything. That means this df is changed. Let's check this df out now. Great. Great. So we have successfully deleted rows based on a particular condition. Let's see, we can delete a column as well based on a specific condition. For that, once again, this is the example. I have read the group data again inside the data frame, and these are the columns we have. And now I want to delete one of these columns based on some condition. And let's suppose the condition is that I want to drop all those columns from here that has more than two NaN values. And if you see that we just have these three columns which have NaN values. Subject 1 and subject 2 have 15 non-null values. Since we have total of 16 records, so that means subject 1 and subject 2 have only one null values or NaN value. And this scholarship has two NaN values. So let's suppose that I want to delete all those records which have more than or equal to two NaN values, and scholarship is one of them, one of the candidate. So it has not more than 2, it has greater than equal to 2. It has greater than equal to 2. Okay. Great. So for that, let's see what I'm doing right now. Once again, I am using the drop method. And to the drop method, I have to pass the columns, and the columns is a list of these values. So this is a function that I have passed to this, and a function once again using this lambda. It says to all the values apply this function. If call is null and the sum is greater than equal to 2, so over here it will calculate the sum, over here it will calculate the sum of the null values, the sum of the null values, over here it will calculate the sum, and wherever the sum of the null values is greater than equal to true, it will return true, and for that this column will be dropped. Let's see this and verify that as well. So we have dropped that column, and that is great. That is great. Of course, my dear students, if this is not making much sense to you, don't worry much, because we are going to handle the null and the NaN values in detail in our upcoming session, inshallah. Let me move ahead and let me tell you we can change the data type of a pandas series as well as the data frame. Let's suppose that this is once again the default data set, and I'm using this as type method. I'm just changing the age. This age is right now having the data type int 64. For whatever reasons, I am changing it to float. So I'm using the as type to cast a pandas object to a specific data type. And of course, I'm assigning it to this age. And after that, I'm verifying. You can see that this age has been converted to float from integer. And you can see the output behavior as well. This age is now 52.0, 51.0, and so on. And similarly, my dear students, you can change a string data type to a boolean as well using a trick like this. Let's suppose that we have this data frame, and you see that over here inside under the gender column we have just two values, male and female. And let's suppose that I want to keep 0 for 1 for the male and 0 for the female. Let's suppose that what I'm doing is I'm just using the string method on this gender column. I'm using the contains method of the string class on the gender method on the gender column over here, and it is returning me a series containing true or false. So for male it is returning true, for female it is returning false. And I'm just using the as type again to cast it to int. So I have 1 for true and 0 for false. So this is a little trick. This is one way of doing that. There are other ways as well using which you can do that. And then finally I have assigned this new list to this gender column. So this gender column was previously containing this male and female, this categorical values, and now you see we have these numeric or Boolean values. So great, great. Okay, the last thing, that is sorting of the data frames. My dear students, there are two methods that you can use. Mostly we use the sort values method. The sort values method is passed lot of parameters. Make time to read this page or see the help page of the Python. Let me show you different use cases that you will come across with this uh, sort underscore values method. So I have generated a new small data frame to make you understand this. So this is having roll number, name, gender, grades, marks, and city, and these are the total of 5 rows in this data frame. We can sort by a single column. You can call sort values on this data frame, and you can sort by a single column. You can just pass the name of that column. However, you can use the name of the argument, that is by is equal to, and you can pass it as a list. So I have over here, I'm passing it with a list. So this time this will be sorted by the grade column, and instead of using the head, let me see all. Doesn't make much difference. Oops. So it has this 1, 2, 3, 4, 5. Great. So they have been sorted by this column. Okay. Do make a comparison. Okay. But just note, in this output, we have sorted the data frame on this grade column. Oh, moreover, you can observe that there is a marks column, adjacent marks column, and there are certain students who are having the same grade but less number of marks, and they are coming up. So this Kamal should not have been here. This Saima should have been on the first place, because she is having the A grade and having the maximum marks, 23. So this means we actually want to sort by 2 columns. So we can do that using the sort values. So let's see, we just pass the 2 column names, the grade and marks. Let's see that. Note that the grade column and the marks column, they are both sorted, but our problem is still the same. Rather, it has been aggravated. Previously, Saima should have been at the first position. She was at the second position, but now Saima has gone to the third position. Can anybody tell me what has happened? Well, yes, actually by default, this sort underscore values method is sorting in ascending orders. So A has come first, and then we have B, and over here we have 20, 21, 23, and so on. Actually, what we want is, we want to sort this grade column in ascending order and the marks column in descending order, so that this Saima record should come first. So we can do that as well, and that can be done using the ascending argument. We can pass the ascending argument to sort underscore values method, and you can pass a list to it, and this list will say that ascending is true for this grade and ascending is false for these marks. So I think our job will be done. Great. So Saima is at the top, A with 23, A with 21, and A with 20. And one more thing, you can observe that the indices has been randomized now, because the indices, remember, they stay with the record. So if you don't want these indices to stay with the record, which most of the time we do not want them to stay with the index, rather we want them to stay in a particular sequence. So you can of course call the reset index method on this. Great. So we have called the reset index method. And one more thing, observe that now, although the indices have been resetted, but the previous index column has been added inside the data frame as a data. So actually we need to pass drop is equal to true argument to reset index to handle this. So we need to pass the drop is equal to true argument. And of course, over here it has returned this data frame, and if we want to make it happen, so we make in place is equal to true, and let me once again do it like this. So remember, it has not returned anything, but it has of course changed the data frame, and we can verify that over here. Great. So let's see the behavior of this on NaN values as well. For that, once again, I have used the same data set. So this is the data set. You see we have this NaN value and this NaN value. We have two NaN values under the scholarship column. My dear students, let me sort by sort underscore values by this scholarship column, and let's see where these NaN goes. Okay. Okay, so these NaN goes at the bottom by default, and if you want these NaN values to come in the beginning, you can pass the argument NA underscore position is equal to first to this scholarship, this sort by values column. So NaN has come in the beginning. My dear students, this is a very powerful function. Whenever you have to check out, you can check out the help page of this sort underscore values, lot of arguments, lot of parameters, and lot of help available for this. Okay. Do check out for the n largest and the n smallest method as well, which return the first n rows ordered by columns in descending and ascending orders respectively. And finally, the df data frame sort index method. By difference, the sort values method sort by the column, data column, and sort index sort by the index column. Do read this. I've prepared once again a sample data set for you to make you understand this sorting. So, well, this sort index method is going to sort by this index. So, you can pass the axis argument with a value of 0 or 1 to sort it by these row indices or the column indices. Over here I have passed axis is equal to 1, and remember, as I have said, this axis argument play a vital role in many of the operations performed in data science. So axis is equal to 1 is the horizontal axis that move from left to right. So you note that this data frame has been sorted from left to right, sorted by the column names. You see, this city has come first, then gender, then grade, then marks, then name, then roll number. So we have sorted it by the column names. Let's see how we can sort it by this row indices. Okay, the first thing is that why do we need to sort by index? We can see in this data frame as well, the row indices are in numeric order 0, 1, 2, 3, 4. And if the row indices, let's suppose, are disturbed due to some maybe sorting by the values on some column, we can use reset index to make the new row indices again in increasing order. So anyway, let me explain this by using an example. So let's see that we have this data frame, and I just want to make the roll number as the index, roll number column as the index column. So we have made the roll number column as the index column. Okay, note that this column is dropped, implicit index column is dropped, and now this roll number column has become the index of this data frame. Let me use the sort underscore index method and pass it axis is equal to 0. Axis is equal to 0 moves from top to bottom. So it will sort this data frame based on the index, and that is roll number. You see, 102, 101, 104, 105, 103. This time over here it has been sorted. And remember, the records stay with the index. SIMA 101, over here again SIMA 101. Sheikh was at the end with index of 103. Sheikh is now at the third position with index of 103. So once after you have done this, you can use again the reset index method to reset it, and we have successfully resetted it. The roll numbers are now sorted. We once again have the row indices which are 0, 1, 2, 3, 4. Great. Well, my dear students, that is all for today's session. I have tried my best that in these two sessions of the Pandas, I should try to explain all possible use case scenarios which you can come across in your data science career to modify data frames. So that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, Please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.